Warning: the opinions presented on the Meteorite Woman channel challenge mainstream scientific theories and test our most basic a priori assumptions about our planet in search of novel insights to age-old mysteries. The hypotheses I will introduce you to arise from my own thought experiments and studies. Viewer discretion is advised, for questioning reality as you know it can leave you feeling unsettled. And with that, I would like to welcome you all to the Meteorite Woman channel. Thank you for coming and joining me. Today I'm going to talk about my electromagnetic impact theory. I'm going to break it open for you. And one of the first things that I learned when I was learning how to identify meteorites was that they are almost all magnetic. There are some exceptions to that rule, but as I'm demonstrating here in this video, they are attracted. They're not magnetic. They're attracted to magnets, I should say. And we also know that Earth happens to be a gigantic magnet. So it kind of stands to reason. You know, if A is attracted to B and C equals B, then A is attracted to C, right? Right. So that must mean then that our planet is attracting magnetically these magnetically attracted rocks to it. It only makes sense, right? And this is where it gets really exciting because we can take what we know already about magnets and magnetism and apply them directly to this scenario to make other hypotheses. For example, we know that the strongest magnetic fields of any magnet occur directly at the poles, right? But Earth isn't shaped like a horseshoe magnet, it's shaped like a sphere. And so we can expect that the strongest magnetic fields to occur at the north and south pole of Earth, which means that the poles are the areas that are most likely to be impacted by meteorites. So the most frequency and potentially the highest magnitude impacts would be expected. And this sort of makes sense, right? Because the poles are not, they're very inhospitable, they're somewhat uninhabitable, and they have some really crazy geology going on. I mean, this to me looks like an impact crater. It looks like the bowl of a crater. But there's only one problem with magnetic impact hypothesis, and that is all the ice and snow at the poles. It just doesn't seem to fit, right? Because impacts generate a lot of heat. And so it doesn't seem to fit that then the poles would be frozen rather than the warmest places on Earth. And so for a few months, I assumed that the hypothesis was incorrect until I came across this information. This is from littleastronomy.com. It's a little map of where all the meteorites in the world have been found, or at least all the reported findings. And what jumped out at me when I found this was this right here. There is a notable absence of found meteorites right over South America. And this jumped out at me because I had already been aware of this, something called the South Atlantic Anomaly. And if you've never heard of it, what it is, area of low magnetism over South America, this made me sure that magnetic impact theory is correct. But I needed to find an explanation for all the ice at the poles. Why are the poles frozen if all this heat is being brought to them? And so magnetic impact theory languished for a few months. until I noticed something very interesting, that we have glaciers that exist right on the equator. That's right. Here's one. These are snow-capped volcanoes. And there are tons of them all over the world. I already suspected that volcanoes and impacts were strongly related somehow. And when I saw all the snow caps and glaciers that existed in warm regions on top of volcanoes, that made me start to think about the composition of meteorites. Where do they come from? They come from asteroids and comets. Both are known to contain hydrogen. Comets, we know, actually contain water ice. And we know that asteroids contain hydrogen, which once they impact the lower atmosphere of Earth, this would result in the generation of water. As the molecules of hydrogen combined with oxygen, they would create water as a byproduct of an impact. And once I understood that, I had an idea. If water is a byproduct of impacts, then maybe it does something weird when it's put under a lot of pressure and heat. And so I looked it up. I just plugged into Google, water under extreme pressure and heat makes ice. And there it was. I mean, this had been screwing me up for months, and here I found the answer. This is super ionic water. Ice formed under extreme heat and pressure. Now, this was just discovered in 2019. It had been hypothesized for like 30 years. Some computers modeled it, but they had never been able to actually create it. But in 2019, it was created in a lab for the first time. And so I found a nice article about this entitled "Black Hot Ice May Be Nature's Most Common Form of Water." I'm not going to read you the whole article. I'll spare you that. But there are some key points that they talk about in here. They describe it as a new crystal, but with a twist. All the previously known water ices are made out of intact water molecules, each with one oxygen atom linked to two hydrogens. But superionic ice, the new measurements confirm, isn't like that. It exists in sort of a surrealist limbo, part solid, part liquid. Individual water molecules break apart. The oxygen atoms form a cubic lattice, but the hydrogen atoms spill free, flowing like a liquid through the rigid cage of oxygens. So it's like nothing they've ever seen before. They actually called it a new form of matter. It conducts electricity, and that it would flow over time. That it's black, it's conductive, and it's a solid that flows. So I looked it up. Is polarized black? I'm going to go off on a little side tangent here. So I found this, and this kind of stuff is starting to drive me nuts. But hold on, let's go back. It seems like journalists cannot get articles published unless they throw something in there about climate change. It's in like every single news article now. It's like they all follow this narrative. Here's this bad thing that happened. We don't know exactly why it happened, but we're going to chalk it up to climate change. That is the narrative. That's how every single one of these stories unfolds. And I've seen it happen with a polar bear attack. And we're talking about an apex man-eating predator known for attacking humans. And some news article tried to blame a polar bear attack on climate change. It's ridiculous. Last year also, when they were talking about like the crab season up in Alaska, like opilio crab and a couple of types of crab, the numbers were too low, and so they called the seasons off last year. Fishermen were not allowed to fish, and they blamed it on the higher temperature waters in those areas. But nobody had actually done any scientific research to confirm this is true. They just made the assumption that that's what caused it. Meanwhile, I looked up on USGS website and I found that in the mating season leading up to that, the fishing season, there had been some earthquakes in key spawning areas. So that, I think, was much more likely to impact the reproduction of the crabs. So, I mean, I'm no scientist. I'm just saying, and I'm not saying that's what it is. I'm saying that there are other possibilities that exist, and it's very lazy, and it's dangerous to assume that everything that's going wrong is because of climate change. And it's scaring the shit out of people, and it's making everyone feel like there's no hope for us, like that the planet is just on its way out and we're all to blame. And I don't know that that's true, but they're really throwing a lot of information at us to make us believe it. And so all I'm saying is, hold on. Let's not jump to conclusions. Let's look at all the evidence before we decide, especially when people are talking about doing things like, seeding our atmosphere with things that are going to lower the temperature of Earth because we assume that this heating is catastrophic. Folks, the jury is still out on this. It's not a foregone conclusion. And I know that's controversial to say, I'm sorry, but that's it. I said my piece. We'll do some more. I'll do some more episodes about this topic. But anyway, here goes. This article follows exactly the narrative. And so here we go. They have this dark ice. And they're saying that dark ice forms when dust, soot, and algae settle on ice and turn it into a dark black hue. This change in color causes the ice to absorb more heat, and then it melts faster than normal. Now, I could see why that would be alarming, but at best it's irresponsible to assume that this is all being caused by human activity. So here's what the phenomenon is. Dark ice is where the upper layers of an ice sheet or glacier become coated with dark colored particles known as cryoconite. Okay, so I looked up pictures of it. This is what it looks like. I see that it does melt right through it. Kind of like rock salt, except black. So that tells me it could have some mineral content and some salts. And meteorites are known to contain those substances. So I looked up cryoconite meteorites on Google, and I found this. And here we go again. From minerals and organic, look at the title, cryoconite, from minerals and organic matter to bioengineered sediments on glacier surfaces. What they say at the end is the mineral matter covering the ice surface originates from various sources. And the very last one they mention is, and even extraterrestrial matter, e.g. micrometeorites. Oh, I should look that up, that Moret et al., 1987. Well, I don't know if I have to get into that much detail, but just to show you that there are alternative explanations than what was being drilled into our minds. So then I looked up black glaciers. But as you can see, it's not just on the surface. I mean, it's absolutely beautiful. This is, it permeates the entire sheet of ice. Look at that. That's dark. That's blue and black through and through. This is it. Here we go. We're inside one. The blackness goes all the way through the inside. You can't tell me that that floated there from some wildfires. Yeah, and that's what that article was saying, that like it comes from soot, from particles of, you know, using fossil fuels and wildfires, and yeah, all that may be true, but I kind of think that there's probably a higher percentage of meteorite dust in this stuff than anything else. So, and some of these are quite beautiful. I mean, look at that. It just tell me that wasn't all delivered in one package. Okay, you can see the lines through it. That's why it's like pressed into the earth. It's just coated with black. So that didn't float there from some wildfire. Look at it. It's permeating through. And this is just a solid black chunk of ice. So I say bullshit on that article. Now, the article about the superionic ice mentioned that it would conduct electricity slightly. And so I looked that up too. Does glacier ice conduct electricity? And to my surprise, I found a research paper that says, in general, the conductivity of snow and glacial ice is found to be much higher than that for pure ice. So, okay. And that's from 1960. That's been known since 1960. So there's another little piece of circumstantial evidence. And here comes my third.
Although glacial ices are solid, it actually flows like a river.
Did you hear that? Now look at it. This is a solid flowing like a river.
This camera shows that Nigod's surface ice travels at around 275 meters per year, carving away the rock as it goes.
I found another article entitled from January 26, 2022, University of Washington News, entitled Glaciers Are Squishy, Holding Slightly More Ice Than Thought. And in it, Professor Brad Libovsky says, and I quote, on short time scales, the glacier is a solid, and on long time scales, it's a fluid. So we have a solid behaving like a fluid that conducts electricity and is black. And that brings me back to this slide. Properties of superionic ice: black, conductive, a solid that flows. So far, this stands up to every bit of scrutiny that I've applied to it. And that's why I really have to share it with the rest of the world. I'm suggesting that meteorites are magnetically attracted to Earth, that the magnetic poles are impacted most frequently, and that glaciers are made of superionic ice formed in impacts. And that's where I'm going to leave it today. I want to thank you for your time. And please, if you have any questions, please leave them below. I would love to answer them for you. And I would love to hear your thoughts on the stuff that I'm talking about, because it really does challenge some of the things that we thought we always knew about the Earth. And it's interesting to me that no one else has even considered this possibility that they're magnetically attracted. So my next episode, I wanted to keep these a little short, easy to digest. My next episode is going to be, we're going to talk about how the Earth's atmosphere affects meteors as they are impacting Earth. And that's going to be a real fun one. So I thank you for your time, and I hope you have a great week. Talk to you soon.